Hello, so in this video we're going to start talking through Theme 1 homework. Now Theme 1 is all about representing data. So we start off with some definition checks. Okay, so the first definition, what is the study of statistics? Well, quite simply, statistics is just the study of variability. You know, things in the world, they change, right? And statistics is all about measuring that change and observing that change and trying to understand that change, okay? Yes, some people might say statistics is all about making decisions based on evidence. That would also be totally fine, okay? But I'm going to stick with my definition of variability because at the end of the day, things in the world change, okay? And ultimately you want to try and understand that change, and sure, you collect data and you use evidence to understand that, so that's all fine, okay? Part B, what is variability and why is it important in statistics? So variability, trying to link it back to part A, is just simply how do things differ, okay? How do things differ? Now we've actually looked at a measure of variability, like standard deviation, we've looked at range, we've looked at interquartile range, you know, we've looked at deciles, percentiles, all these kind of things. They all help us to understand variability in data. But more generally, why is it variability important in statistics? Well, statistics is simply the study of how things change, okay? The study of variability. So therefore, the reason why variability is important in statistics is because it's measuring how things differ. For example, if you walk into one class and the average test score is 100, and you walk into another class and the average test score is 130, you want to understand that change, okay? Is one class better than the other, or is it actually just a pure fluke? And obviously there's all the different things that you need to factor into that, okay? So that's the reason why variability is important in statistics. Part C, what is a population? Well, a population is the entire group of interest. For example, everybody in the college, or everybody on the university campus, or every single type of chocolate bar that's ever been made, or everybody in the world. These are all examples of populations. It's the entire group, every single member of that group that you are interested in, okay? Whereas a sample is that subset. So you know, we talked quite a lot about the difference between samples and populations. It's really at the heart of what's going on with this course, okay? And if you can get your head around that, you're on the way to sort of understanding the key concepts in this course. But yeah, a sample basically just takes a subset. As we've established, it's nigh on impossible sometimes to collect a data from the entire population. Instead, you just need to look at a sample. And as long as your sampling methods are good, and we've looked at different types of sampling methods, random versus biased sampling, you know, you've got stratified sampling in there, you've also got opportunity sampling, all these kind of different types of samplings which we've looked at, okay, then usually that will be enough to understand what's going on at the population level, okay? And really statistics, or the heart of what we're looking at in this course, is understanding how we can relate what's happening at sample level to what should happen at a population level. Okay, next question. What is a statistic? Well, statistic is just simply either a measurement, characteristic, or descriptor of a sample. So it's really important. Remember, statistic for sample, okay? Statistic, sample, okay? So if you're looking at, for example, mean or standard deviation of the sample, that is a statistic. It's a way of describing what's happening at the sample level, okay? So you've got all this data and you're trying to describe that data. It's a characteristic or a descriptor or measurement of that sample. Okay. Whereas on the other hand, a parameter, similar kind of thing, but you're looking at it at the population level. So remember, sample for statistic and population for parameter. Okay. So parameter is again a descriptor or characteristic of the entire population. So for example, if you are trying to understand everybody that sits a particular type of test in the entire country. Okay. So imagine it's a GCSE exam or something. It's going out and everybody in the country is sitting it, and you want to understand what is the average test score, okay, that would be a parameter. That's the thing which you're trying to understand at the population level. And in order to do that, you collect samples. So you might collect sort of multiple different tests, sort of from different schools, and yeah, you look at the average test score on that sample, and that will give you information about what's happening at the population level. Okay, what is a census? Well, a census is basically what happens if you go out and collect data from the entire population. Now, we've looked at the advantages and disadvantages of censuses. They're usually very expensive, both in terms of collection, but also in terms of actually analysing the data. So we tend not to do that very often. But there is a census that takes place in the UK, for example, every 10 years. And that is enough to make predictions on things like housing and the economy and the sort of places where the government should invest money. Okay, and it's enough to make predictions over the next 10 years. And then you update those, you update that evidence every 10 years using a census. But it's very expensive and it can be quite difficult to analyse and collect. Okay. What is data? Well, data is just the raw information that is collected or measured. Okay, so you go out and you might want to measure heights. So you measure heights of everybody in the class. Okay, that would be data. Each individual height would be the data. Okay, so it's the raw information that's collected or measured, and then from that you can form either your statistic or your parameter, depending on whether you're looking at the sample or population level data. Okay. Categorical variable. Well, a categorical variable is data which can be put into categories, okay, and these are usually textual information. Another word for this sometimes is qualitative variable. Okay, so basically an example of this would be something like gender, okay, or eye color, right? These are things which can be put into particular categories. So for example, everybody that is male, female, or other, they can be put into those categories. Or it might be mood, you know, how are you feeling today, right? That is an example of a categorical variable because you can put that into particular categories. Whereas a numerical variable, otherwise known as a quantitative variable, is data which are represented using counts or measurements, okay? So as an example, you know, measuring the heights of people in a class or measuring the weights of a particular type of chocolate bar. These are all examples of numerical variables. They're usually things which result in numbers or quantities. Okay, discrete versus continuous variable. Well, a discrete variable is a variable that can only result in a finite set of values in a given interval. In other words, it's only going to take specific values. It can't take every single possible value. An example of this would be shoe size, right? In the UK, you can either have like a size 3, size 3.5, size 4, size 4.5, size 5, size 5.5, etc., etc. You can't have a size 3.1. Okay, so that would be an example of a discrete variable. Another example would be age. You can either be age 1, age 2, age 3, age 4. You can't be sort of anything, you can't be, for example, the values in between. So age is usually given as a discrete variable. Okay, you know, think of discrete variable as almost like traveling along a lift. Okay, you can only get off at set floors. Okay, in other words, a discrete variable means that you can only take specific values. You can't take any value you like within the given range. Whereas on the other hand, a continuous variable would be a variable that can result in any real value in the given range. Okay, so an example would be height. Okay, the height can be any real value within a given range. Okay. Okay, good, fantastic. So let's move on then. Let's have a look at question 2. So I've given you some data here representing heights of a sample. Now I'm just going to put a ring around the fact that it's a sample because that will come into handy later, of randomly chosen students in a class. So it's a random sample and these are the heights of these students. I want to calculate the mean. Mean is very simple. I just need to add together all of these values. So 150 plus 148 plus 152 plus 159 plus 165 plus 162 plus 168 plus 174, and I need to divide it by the number of things that are in my sample. So I need to divide it by, well, there's 1, 2, 3, 4, 5, 6, 7, 8 things in my sample. Okay, so I need to divide it by 8. Just remember the formula for population mean and sample mean is virtually exactly the same. Okay, so you don't need to worry about dividing by n minus 1 or anything like that. Okay, so I'm going to stick all of that in my calculator. So let me just bring my calculator up. Okay, so my calculator, in fact, I might just move that over slightly if I can. Okay, so I've got 150 plus 148 plus 152 plus 159 plus 165 plus 162 plus 168 plus 174. Get all that equal, so it's all equal to 1278. So actually I'm going to write that down now. So I'm going to write down 1278. It says I need to divide that by 8. So then I've got a record of it on my paper. So if I'm marking this in an exam style sort of situation, the examiner can see, right, okay, this is how I've got my answer and I've got the correct numbers along the way. Now actually in this case, if I press on and go, oh no, I've lost it, what's happened? Doesn't matter. You see this key down here with ANS on, it simply takes up the previous answer that was on your calculator. So if I press ANS and equals, it brings back that 1278 for me. So even if you turn the calculator off, right, if you've got the ANS button on, it basically means that you can use the answer that was previously saved on your calculator. Then I can just do that, divided by 8, and I can hit equals, and that'll give me, I want this as a decimal. This is meaningless to me as a mean, okay? As a mean, I want it as a decimal. 1639 over 4, that's meaningless. So what I'm going to do is press S to D, and that'll convert it to a decimal for me. So my answer is going to be, and I'm going to put it on the dotted answer line, 159.75. Okay, fantastic. Next question is asking about standard deviation, okay? So there's a couple of different formulas for standard deviation. First of all, are we talking about a sample or population? Well, we're told in the question it's a sample, okay? Which means we're going to need to divide by n minus 1. So first things first, I'm going to calculate variance, okay? So I'm going to calculate s squared. So in order to calculate variance, a couple of different formulas. I'm going to go for 1 over n minus 1 times the sum of, well, I'm going to square all my values, okay? Then I'm going to take away n lots of the mean squared. I'm going to go for this version of the formula over the other version of the formula, which remember is 1 over n minus 1 times the sum of x minus x bar, all squared. Of course, when I say x, I actually mean xi, okay? The reason why I'm going to go for this version of the formula is because I think it's going to be easier to square all the values than add them all together because I've already got this sample mean. The sample mean up here is 159.75, but it doesn't matter which version of the formula you're going to use. All right, fine. So 1 over n minus 1. Well, 1 over n minus 1, there are 8 things in my data set. Okay, I counted those right at the very start. There's 8 things in my data set. So therefore, n minus 1 is going to be 7. So it's going to be 1/7 of. Now I need to add all of the squares of my numbers together. Okay, now I'm going to show you a quicker way of doing it in just a second using your calculator. But for the meantime, I'm literally going to take each of these individual values, square them, and then add them together. Okay, so I'm going to take 150 squared plus 148 squared plus 152 squared plus 159 squared plus 165 squared plus 162 squared, I'm going to go off the screen slightly, plus 168 squared plus 174 squared. Okay, so these are all of my numbers all squared and added together. Okay, then I'm going to take away, so I'm going to put it down here, I'm going to take away n lots of the mean squared. So n is 8 and I'm going to times it by the mean squared. Well, the mean I've just worked out is 159.75 and I'm going to square that. Okay, so let me do it in pieces so I'm not doing it all in one go on my calculator. So I'm going to do 1/7 first of all. All right, so now I'm just going to do the square. So I'm going to add all these values together and I'm going to square them all. Okay, so square them all. So it's going to be, so let's clear it, AC, 150 squared plus 148 squared plus 152 squared plus 159 squared plus 165 squared plus 162 squared plus 168 squared plus 174 squared. Press equals, and I get that as 204,758. It's 204,758. I'm going to take away, so now I'm going to do the 8 times the 159.75 squared. So 8 times by 159.75 squared. Remember, if I just type that, it's only going to square the 159.75. It's not going to square the 8 as well, which is exactly what I want. So that's going to give it to me as a decimal, please, 204,160.5. Okay, now I'm in a position, now I've broken it down, I can actually just get away with typing that alone in my calculator. So here we go. So I'm going to clear it. I'm going to press the fraction. I'm going to do 1/7. So 1, oops, didn't press the fraction button. There we go. So 1, then down, 7. Now I'm going to open a parenthesis. So I'm going to press that button there. Then I'm going to do 204,758 minus, then I've got my 2. Well, actually, that's going to be my previous answer stored in my calculator. So actually, I can just get away with just hitting A and S there. That's fine. Close the bracket, hit equals, convert it to a decimal, and I get myself 85.4. Okay, just leave it to one decimal place. That is fine. Okay. Now, temptation is to leave it there, but just be aware we're talking about the standard deviation. So that's the variance that I've just calculated. So in order to get the standard deviation, I need to square root it. So the square root of 85.4. So I'm going to stick it here, over here on the right hand side. In fact, I'm just going to make everything else just a wee bit smaller, just to make sure that I can fit it all on the same page. So let's just fit it all down, scooch him over here. There we go. Okay, so now all I need to do is just take the square root of my answer. So if I bring my calculator back, bearing in mind that this is now my answer, okay, so if I clear it, I can just go square root, that button there, then A and S, which is that button there, hit equals, and I get myself 9.24. That's totally fine. It's 9.2, 9.24 is totally fine there. Okay, so hopefully that makes sense. Now, I said to you, this is fine, okay? You can do it all manually by hand, but it takes quite a long time. And really, this is just sort of monkey maths, I call it. It's the kind of thing which you don't really need to know what's going on. It's just purely calculating stuff. So there is an advantage if you've got a calculator like this. And in fact, if you've got an online calculator, it's fine, but you can also do it on a scientific calculator. You can do all these calculations very, very quickly because there's an inbuilt statistics mode that is designed to give you these summary statistics, which I'm asking about here, okay? So the way to access this is to first of all change the mode of the calculator. So in order to do that, you need to come into menu, okay? And then you'll basically have to choose, so at the moment we're on calculate, so we're using it as a calculator, okay? But you can change this into statistics mode. So if I press 2, or if I navigate to the right, okay, you can see that I can change it to statistics mode, and obviously the last one is a table mode. But we want statistics mode, right? So to enter that mode, we just press equals. Then you have a few different options, okay? Now some of this will become a little bit sort of, you will recognize this later on, particularly option 2, which is a regression line, so that we'll meet that in theme 6. But for the moment, we just want one variable, okay? So in this case, we're just looking at sample data that's only got one variable in. In this case, I think it's the heights of the student, so it's one variable. So I'm gonna hit 1, okay, and then it'll basically bring up a little table here. Then what I can do is actually enter the data which I've been given, okay? So if I actually enter the data which I've been given, so I'm just gonna put it in, so 150, and then to enter it, I just press equals. And you can see it's been put in that top line of the table, okay? So 150, then 148, then 152, then 159, 165, 162, 168, and 174. So let's just quickly check to make sure I've got all that right. So we've got 150, 148, 152, 159, 165, 162, 168, and 174. Cool, excellent. Now that's stored in my calculator. Okay, so I can actually go back to my main screen. So I'm just going to press AC to take me back to my main screen. And you can see it's now changed because I'm no longer in the calculator mode. I'm in the statistics one variable mode. Okay, it's changed the sort of what's appearing down here. So now I just need to go into options. Now this is different on different calculators, okay? So I'm just showing you how it works on the ClassWiz. It might be slightly different on the calculator which you're using, but that's fine. There'll be either a statistics option or in this case just the option key. So if I hit that, I've got a few different options, okay? So I can either select the type of data, I can actually do the one variable calculations, or I can select the data again to change it, okay? Now in this case I want option 2, which is the one variable calculations. I want to do calculations on this, okay? I want to give me summary statistics without me actually having to type it myself. So I'm just going to hit 2. And then what this brings up is basically a list of numbers. And you might recognize some of these numbers. For example, the top one, X bar, that is the mean, right? And that mean is exactly the same as the mean that we calculated, 159.75. But you've also got calculations such as sum of X squared. So you notice here, when I did sum of X squared, I physically had to square all the values and then add them all together. Okay, and the thing is, by doing so, it's kind of opening the door to mistakes. So if you can just type it in your calculator, you've got that number automatically. So the 204758, I got that there. Okay, so I could do it for my calculator automatically. Okay, and I've also got things like the standard deviation of X. Now in this case, this is population standard deviation. You notice the difference between sigma and the S. Okay, so if I'm using sigma here, if I'm using sigma, it means I'm talking about population, and if I'm using S, it means I'm talking about the standard of this sample. Okay, now in this case, I'm talking about sample data. So therefore, I just scroll down, so I just press the down arrow, and you can see the next one along, so S will give me the 9.24, which I calculated for my standard deviation there, okay? You might be saying, well, hang on a minute, why is the standard deviation for the population different from the standard deviation for the sample? Reason being is there's a sampling correction going on there, and we'll talk about that more later on when we talk about the central limit theorem. But in this case, because we're talking about sample data, because we're giving it data, you want the S one. But you can also things like the Q1, the Q3, the median, the minimum, the number of items, and also the maximum. So particularly if you're drawing box plots, all that summary data is there. Now, the big thing is, I've shown you how to do this, okay, and I've shown you how to do it on a calculator, and you will have a calculator in the exam. There's no issues there. But the question is, because you can just stick it in your calculator and the calculator will tell you the mean. So for example, for question 1, when I was saying give me the mean, okay, in this case it's just one mark, so it'd be fine just to give me the mean there. But I do want to see how you've calculated it, okay? So just stick it in your calculator is not enough to achieve all the marks, particularly for the second one where there's more things going on, there's 2 marks going on. If you just give me the final answer with no working because you just stuck it in your calculator, you will get 0. Okay, you have to show me that you've understood the process to get to that answer. Okay, if you just stick it in your calculator, I'm not interested in that. Okay, I'm not interested, can you use a calculator to calculate this? I'm actually interested in, do you understand what you need to do in order to get this final answer? So what I'm trying to say is if you just stick it in your calculator and just use all the answers in your calculator, you will not get the full marks. Okay, in order to get the full marks, you have to show me method to your calculation. So in this case, what I would do is actually use the calculator as a check. Okay, I'd use the calculator as a check to get to my final answer. Okay, or what I might do is just write the working down manually, but then stick the numbers in my calculator so the calculator will give me the answer itself. So I don't actually need to stick this big fraction in my calculator. Likewise, I wouldn't have to stick these all squared values being added together in my calculator. Okay, so just be aware of that. Yes, the calculator is there and I strongly encourage you to use it. However, you still need to show me knowledge. Okay, if you don't show me knowledge, you won't get the marks. So use the calculator as a check. Maybe use the calculator to do the big, long, horrible calculations which you can't be bothered to do, but you still need to show me on paper the process which the calculator is doing to get to that answer to show me you've understood that. Okay? So by the way, if you've got into the statistics mode in your calculator, you want to get back to the old mode, very easy, just go Shift and then that button, so get into the setup, sorry, wrong one, get into the menu button, so you want to go menu or mode, and then you can change that back to calculation, so just hit 1 and then it's back to the calculator mode as it was before, okay? So just to show you that again, if you want to get back into calculator mode, just hit your mode or your menu and you want to go back to number 1 and then you're back into your calculator mode, so nice and easy. Okay, so let's have a look at the next question then. So actually in this case, I think this will be a perfect example for me to use my calculator to do all the hard work for me. Okay, because I'm getting box plots. I've been given some data. Now, ordinarily, you would need to order that data, then find the maximum, the minimum, the median, and the upper and lower quartiles. I can just stick all of that in my calculator. So let's bring my calculator up. Let's get back into the statistics mode. Okay, so I'll go into the menu and I want number 2 for statistics. And it's going to be one variable because in this case, it's just the weights or the number of crisps in each packet. Okay, then I can basically type these numbers in here. So you see the numbers which I've been given, 44, 52, etc. Okay, I can just type this in, so 44. So 44, and then press equals, then 52 equals 58, then equals 58 equals 44 equals 53 equals 32 equals and 61, and then finally 60. Okay, fantastic. So now if I press AC, okay, I can go into my option and I just want to see the calculations, some summary data, so I'm just going to hit 2 and then that'll bring me up all of the calculation data I want. Now in this case, I'm actually going to come down because I want this data here. Okay, I want the minimum, I want Q1, I want the median, I want Q3, and I want a maximum. Okay, so in this case, and I can actually write this down, in this case, I know that the minimum is 32. I can tell you that Q1 is 44. I can tell you that the median is 53. Q3, which is the upper quartile, is 59. And the maximum, okay, I'll just scroll down. The maximum is 61. Okay, so I've got that data there and I don't need to worry about calculating it myself. Okay, now it's just a case of putting it in the right place. So remember, I draw a vertical bar at each of these values. So 32 is first, so 32 is here. Then I want 44, which is there. Then I want the median, which is 53. Then I want the maximum, upper quartile, which is 59. Then the maximum, which is at 61. Now just remember, the way which you calculate that is you're looking at the points which are 25% through your data. Okay, I'm going to put a box around the interquartiles, join the last two together with 2 whiskers. Okay, so that's my box plot for the first one, nice and easy. Okay, don't need to label it, just make sure that everything's in the right position. You've clearly kind of put everything in the right position and you're doing a good box plot there. Okay, now I need to compare the data. So I've been given another box plot here, and I need to compare the data for Tasty Crisps to Crunchy Crisps. So the first box plot which I drew was for Crunchy Crisps, and the second box plot which I drew was for Tasty Crisps. Now just remember, if you're comparing box plots, you need to give two pieces of information. You need to give the measure of central tendency and a measure of spread. So just to remind you, I know we've looked at this before, these are the two things you need to compare. Okay, so one measure of central tendency and one measure of spread. So in other words, measure of central tendency will tell you the average value, and the measure of spread will tell you how spread out the data is, the consistency of your data. Okay. Now the first thing you need to ask is, are there any outliers in your data? Well, remember, in order to check whether there's outliers in your data, you need to do the interquartile range, so 1.5 times the interquartile range. So let's find the interquartile range for the first one. So the interquartile range will be the upper quartile, which is 59, take away the lower quartile, which is 44, okay? That's going to give me, what's it going to give me? It's going to give me 15. So the interquartile range for the first one is 15, okay? If I calculate the interquartile range for the bottom box plot, the interquartile range is going to be, well, it's going to be from here, which is 46, to here, which is 51. So I'm going to do 51 minus 46, which is equal to 5, okay? So now what I need to do is check 1.5 times the interquartile range. So 1.5 times the interquartile range. So 1.5 times 15 is going to be 22.5, okay? And then 1.5 times by 5 for the bottom box plot is going to be 7.5. Okay, so in other words, for the top box plot, if there are any outliers in your data, I need to measure backwards 22.5 from the lower quartile and upwards 22.5 from the upper quartile. Okay, now as you can see, all of my data falls within 22.5 from my lower quartile and 22.5 above my upper quartile. So there's no outliers in this data, in my first box plot at least. Okay, so there's no outliers in here. But now if I check 7.5 each way from the upper and lower quartile, well, 7.5 take away 46 is going to be 38.5. Okay, so 38.5 is going to be here. Okay, so there, if I take my lower quartile, and if I take away 7.5, there is the cutoff margin for my lower quartile. If I do the same for my upper quartile, well, I've got 51 plus 7.5, that's going to be 58.5. So 58.5 is going to be here. So I'm basically just moving 7.5 above the upper quartile. And if there's any data points which lie outside that range, in other words, if the end of my bars extend beyond that particular interval that I've drawn in blue, so anything outside this interval here, then I know that there are outliers in the data. Okay, so I know then, because there are points outside of that range, the box plot doesn't finish within that particular interval that I've drawn in blue, then there must be outliers in my data. Okay, so because there are outliers in one of my box plots, doesn't matter whether there's one or both of my box plots, because there's outliers in my data, I need to come back to my decision tree to see what measure of spread and what measure of central tendency I should use. So measure of central tendency then, if there are outliers in your data, you should use the median. If there aren't any outliers in your data, you should use the mean. Well, in this case, there are outliers in our data, so I know I'm going to be using the median for my measure of central tendency. So let's do this, okay? So I'm going to be using the median. I need to compare the medians for both box plots. Well, the median for the top box plot I've already been given, it's 53. Okay, the median for the top box plot is 53. The median for this box plot I can read off is going to be 49. Okay, so now I need to compare the medians of the box plots. Now just remember, median is just simply the average, okay? So in this case, because I'm looking at the number of crisps found in each crisp packet, okay, the median will tell me the average number of crisps per packet, okay? So in other words, the higher the median, the more crisps on average are in each packet, okay? The lower the median, the lower the crisps on average in each packet. So I can say the median for Crunchy Crisps, I'm just going to call it CC, that was equal to 53. Whereas the median for Tasty Crisps, I'm just going to call it TC, that was equal to 49. Okay, so therefore, median for Tasty Crisps, sorry, Crunchy Crisps, is higher than for Tasty Crisps. And then you need to put this in context. So it's not just enough to say, this is the medians, and this means that the median for Crunchy Crisps is higher than Tasty Crisps. You've always got to think, so what? What does that actually mean? Well, just remember, the median is talking about the average number of crisps, in this case, per packet. So therefore, because the median for Crunchy Crisps is higher than for Tasty Crisps, it means that there are more crisps per packet on average for Crunchy Crisps. Okay, so that implies that Crunchy Crisps has more crisps per packet than Tasty Crisps. Okay, so always make sure you put it in context. It's not just enough to say, this is the median value, this is higher, and then leave it at that. You need to always put it in context with the scenario you're dealing with. So that was our measure of central tendency. I now need to compare a measure of spread. So if I come back to my decision tree to see what measure of spread I use, well, are there outliers in my data? Yes, there are. We've just established that. So therefore, I need to use the interquartile range. If there weren't any outliers in my data, then I could get away with using the standard deviation. Okay, so I'm going to use the interquartile range here. So if I compare the interquartile range, let's see for CC, for Crunchy Crisps. What's the interquartile range? It's 15. All right, fine. So for Crunchy Crisps, it's 15. For Tasty Crisps, it is 5. We've worked that out. Okay, so therefore, the interquartile range for Crunchy Crisps is higher than Tasty Crisps. Again, that's not enough. I need to say, what does that actually mean? Remember, interquartile range is talking about spread. It's talking about how varied your data is, how spread out your data is. So therefore, that means that Crunchy Crisps has more variability in the number of crisps per packet than Tasty Crisps. Okay, so what that basically means is if you open a crisp packet, you're expecting more variability with Crunchy Crisps than for Tasty Crisps. Tasty Crisps will have roughly the same number of crisps per packet because there's less spread. Okay, there's more consistency, right? Whereas for Crunchy Crisps, because there's more variability, well, okay, sure, it has a higher average number of crisps, but it means that you could get wildly different results depending on which packet of crisps you open, okay? So not very good quality control there for Crunchy Crisps. Okay, fine, fantastic. Let's move on to the next question. These are nice and easy. So histograms need to label the measure of central tendency, mean, median, mode, and we need to describe this type of skew. First one is a symmetric distribution, so there is no skew there. Okay, so I'm going to type no skew there. Also, the mean, the median, and the mode should be roughly the same. So certainly the mean and the median should be in the middle. So mean and median, they're the same. They're in the middle because it's a nice symmetric data set. And you can either say here that there is no mode, or you can say that every single bar is a mode. It's up to you which way you want to interpret this. Okay, let's have a look at the next one. Well, this again is another symmetric data set, so there is no skew. Reason why they're symmetric is because if you have a look, if I was going to draw a mirror line down the middle, oops, let's actually put it in the middle. If I was going to draw a mirror line down the middle, it would be roughly the same on both sides, which means there's not really many outliers in the data. Okay, so it's nice and symmetric. Okay, fine, let's have a look at this then. So, because it's symmetric, the mean, the median, and the mode should be in the middle. So in this case, they're all the same. So the mean is in the middle, the median is in the middle, and actually in this case, there is a clear winner. Okay, it's the bar with the highest peak, which is the mode. So in this case, the mode is that one there. Let's have a look at the next one. Right, this is a bit more bimodal because there's a little peak there, there's a little peak there, but there is a clear mode. There is the mode. Now just remember that the median is the sort of halfway point of your data set. It's kind of like the balance point. It's kind of like if you're going to split the data area in half, you're going to split the area underneath the histogram in half, the median is the midway point. So the median in this case, I think would be about there. Okay. And then the mean, remember, is always skewed towards outliers. So let's think, is it a symmetric data set? Well, no, it's not. I mean, if I was going to draw a mirror line in, if I was going to draw a line there, for example, I couldn't flip it over and it'd be an exact match on the left and right. So there is skew in the data. And if you have a look, there's outliers over here on the right-hand side. Okay, so there's kind of data which has almost been spread out and strung out on the right-hand side. Majority of my data is in here. Okay, the majority of my data is close to that point there, and the outliers are over here on the right-hand side. So therefore, it is positively skewed. Okay, remember that skew describes, well, is the mean going to be attracted towards the left or the right? Remember that the mean is always attracted towards the outliers, so the mean will be out here somewhere, over here towards the outliers, so it's going to be attracted in the positive direction, so it's positive skew. Let's have a look at the next one. So again, this is my mode. The median will be roughly in the middle, let's put it about there. Okay, and again, the mean is going to be attracted towards these outliers over here. This lies outside the general trend of the data. So the mean will be out here. In other words, it's going to be attracted in the positive direction. Okay, positive, remember, is towards the right, negative is towards the left. Let's have a look at this one. Well, it's pretty much the same thing as the last one, except it's been flipped over. So again, I've got a mode here, clear winner. The median will be somewhere in the middle. Let's put it about there-ish. And again, the majority of, the outliers of my data are over here on the left-hand side. Majority of my data is in there, which means that the mean will also be attracted towards those outliers, okay? So in this case, it's going to be negative skew. Negative skew, because the mean is attracted towards the left. All right, fine, let's finish this off then. So we've got a histogram here, and we've got the marks of students who's had a maths exam. Okay, now remember, on the left-hand side here, I've got frequency density. Reason being is because the intervals, the class widths if you like, which represent the range of marks that are in that particular interval, are different. Okay, so some are only worth 5, some are 10, and some are 20. Okay, so in order to get the frequency, I'm going to have to multiply the class width by the frequency density. So I'm just going to create a little table here. Okay, so I'm going to do the class width, so CW, frequency density is FD, and I'm going to do frequency, I'm just going to call that FREQ. All right, fine. So let's do the first one first of all. Well, okay, the class width is 5, because the mark's going from 0 to 5. The frequency density, that's 0.2. So therefore, in order to get the frequency, I need to multiply those two things together. So 5 multiplied by 0.2, that's equal to 1. Okay, if I do the next bar, that's going to be a width of 5 again. The height this time is 0.35, which means that the height is going to be 1.75. Okay, sorry, the frequency, the number of things in that bar is 1.75. Okay, next bar is going to be 5. The frequency density is 0.6. And that means the frequency is going to be 3. Okay, so there's 3 students who got a mark between 10 and 15. Let's have a look at the next one. So the class width is 5. The height of the bar is 0.3, which means it's going to be a frequency of 1.5. Keep going, 2 more. Okay, 2 more. So the next mark is between 20 and 30, which means it's got a class width of 10. The height is 0.1. Which means there's one person who got a mark between 20 and 30. Last one then. Marks are between 30 and 50, which means that there's 20 things, 20 possible marks that they can have. The height is 0.05, which means there's one person who got a mark between 30 and 50. So those are my frequencies. So all I need to do now is just add all those frequencies together. So take 1 plus 1.75 plus 3.1.5 plus 1. So if I type that in my calculator, hit equals, I get 9.25. Okay, so that'll be the solution there, 9.25. Okay. And then finally, if I just make this table a little bit smaller, just so we can see the last question here. Okay. So if I have a look at the last question just simply says, can you state the modal interval? Well, if you have a look, I've actually calculated the frequencies, so the number of students which are in each interval. Okay, so I've actually calculated this. So I just need to pick the one with the most number of students in. Well, that's going to be 3, so that's the third one across. So this is the modal interval. So in order to state what the modal interval is, I need to state what mark was the most common. Okay, so in this case, it's going to be between 10 and 15. So I could simply write between 10 and 15. I'm going to give it as an inequality. Okay, so I'm going to say between 10 and 15. The mark, I've given the letter M. Okay, and I want to include the 10 and not the 15. It doesn't matter whether I include both or one or the others. I don't know where the boundaries of the intervals are, but I'm going to say between 10 and 15. So I'm going to give it as an inequality like that. Okay, so hopefully that makes sense.